Okay, so this is our lesson on averages. We've had a look at one lesson already where we've been looking at the fact that there are actually three averages that we can use if we're trying to analyse information. An average is when we pick one number to represent a list of values or a data set. It's really hard to do that because sometimes the values vary quite a lot. So how do you pick one number that kind of typifies or is kind of representative of all that information? Well, we've got three different options to choose, and I've already done a lesson on the mode and the median. We're going to have a look at the mean average at the moment, and this is probably most familiar to people because it's the one that most people actually assume is the average. So we can actually say of the mean, it's so commonly used that if you talk to most people, they'll if you talk about an average, that's the one they're thinking of. It's the one that's most taught in schools. It's the one that is most talked about in the world. Although the crucial thing is that when people are actually making up averages, they use all three, and unfortunately, people assume that when they hear the word average that it's been calculated in this way. So there's a bit of a gap of knowledge which sometimes people can be misrepresented, or people can make poor judgments because they have assumed that the average people are talking about is the mean. So what is the mean? You might know how to do the calculation. You might not have thought about what it is. The mean value is calculated by redistributing the amounts in a list until they are of equal value. So what I'm going to do is I'm going to show you a picture. Here is, there's four piles of objects here, and let's have a look at the numbers because I reckon you'll be able to work out the mean by kind of knowing what to do. So when we work out the mean, what we're saying is that there's five rectangles here, there's one here, there's four here, and there's six. Now you might know that to find the mean, you add them all up and you're going to divide by 4. So 5 and 1 is 6, and 4 is 10, and 6 is 16. And then divide by 4 is 4. So you might think that the mean is 4, and you would be correct. But what does it actually mean? Well, here's our, let's bring in 4 into play. What we're saying here is that the mean would be 4 high. There, that would be the mean there. Okay. What does it actually mean? Where does the 4 come from? Well, the 4 simply means that if we were to redistribute all the values here, so we're going to take one, 5 is, we're not quite ready. So let's take away the line just to kind of emphasize what's going on here. We're saying that if we can give to one that's low, we keep doing so. So we borrow from the high ones until the low ones are kind of filled in a bit. We can see it's not quite right. And until such points as they all have the same value. That's us redistributing the amounts, and we can see that that's 4 high, and that's why the mean is 4. And the alternative is that you, as you may well have known already, that we can say we've got 5 plus 1 plus 4 plus 6 equals 20. No, equals 16, sorry, my bad. 16, and then we share that out into 4 parts, okay? So let's have a look at how we might set that out. The mean is the sum of all the data values, that's added them all together, divided by how many data values there are. So in our case, the sum was 16, and the number of data values was 4. 16 divided by 4 is 4. So to calculate the mean of data sets, we can write it out. I'd like you to write out the number set that you're using. Don't just write down the answer. And then to display some working here, first of all, you're going to write down the word mean, because otherwise we won't know what it is we're calculating. And the first thing you're going to, although you sometimes can use a calculator, okay, I want to see a fraction written out here. We know that there are 5 numbers, so 5 is going to be on the bottom of the data set. And the sum of them all, and now we could use a calculator, but as much as possible I want you to do it without a calculator. It's good arithmetic practice. You can either list them in a sum at the side if you want to do it that way, or you could do it mentally. There's different ways that you can check. So let's do it mentally here. 13 and 16 is 29, add 17, 39, 46, 66. 66 and 30 is 96. Okay, so we've got 96 divided by 5, and again you could use a calculator, but if you can, why not try and work it out either mentally or using a calculation. 96 divided by 5. 5 divides into 9 at 1 time, remainder 4. 5 divides into 46 9 times, remainder 1. Now we're going to add, because we've got to the units value, we can add a decimal point, put a 1 in there. We've got a 10, so 5 divides into 10 2 times, so the answer is 19.2. Okay, so as far as possible, try and do it. You could, by all means, use your calculator to check your answer, add them up, and then divide by the number 5. Okay, so let's check the second one. Again, there's no point in just writing down a fraction. We've got to explain we're calculating the mean. So there's 1, 2, 3, 4, 5, 6, 7 numbers in this list. We can add them up, they're decimal values. Just be careful as you do. 8.9 plus 4 is 12.9, 13.5, 13.5, 14.5, 15.3, 17.3, 18, 24.1, 28.3, I think. Okay, I'm just going to use, I'll do all this and then I'll see if I'll check with my calculator. The mean, 28.3 divided by 7, that's not going to be an exact value. I'm going to have to round that, I suspect. 28.3 divided by 7. Well, 28 divided by 7 is 4, so there's no remainder there. 7 doesn't divide into 3, so I've got a 0. Remainder 3. 7 divides into 30 4 times. Remainder 2, add another 0. 7 divides into 20 2 times. Remainder 6, and we could keep going on and on and on here. Okay, so 4.042 and so on. If I wanted to round that to one decimal place, then I could see that the answer would just be 4.0. So I'm going to write down 4.0. And because there was a wee bit of decimal work there, I'm going to actually write it. I'm going to check it on my calculator. 4.6 plus 1.8, 2.7 plus 6.1 plus 4.2, 28.3, yep, divided by 7, 4.042, 4.0 to one decimal place. I've got it right. So try that. I mean, it's always good to check your arithmetic and to challenge it. Calculators make you lazy. And this one here, we'll notice we've got some negative numbers. We've also got the number 0. It's really important that you count 0 as a data value. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8. There's 9 numbers, so we're going to divide by 9. Add them all up. Now the negatives, of course, will cancel out. So you've got 3 and 4 is 7. Subtract 7 is 0. 5 and 1 is 6. Subtract 4 is 2. Subtract 1 is 1. Okay, 1 divided by 9. Well, we could write that as 0.111, but you know what? I'm just going to actually leave that as, well, I'm going to leave that as a ninth, or at 0.11 to 2 decimal places. Okay, so we can see that calculate the mean, add them all up, divide by how many there are, but I want to see that fraction written out first of all before your final answer. Okay, so what can we do with that? That's fairly straightforward. We can work back. So another development, once you've practiced doing that, is a wee bit of problem solving here. We can work back if we know the mean. So the mean weight here of 5 boys is 56 kilograms. That means that on average they're 56 kilograms. We know that the weights of 4 boys are 52, 60, 62 and 48. What's the weight of the other boy? So in other words, we're saying we've got 52, we've got 60, 62, 48 and something. It gives us a mean of 56 kilograms. Now we know that the mean is what we got when we added them all up and divided by 5. Okay, so if you think about the 56, the mean equals 56, which is the sum divided by 5. Well, if you multiply both sides by 5 there, then you can see that the sum itself is going to be 56 times 5. It makes sense that the mean is, the individual value would be 56 if it were all shared out. So in other words, the sum is 5 lots of 56, which is 250 add 30, which is 280 kilograms. So it means that the total, if we added up all 5, would be 280 kilograms. So if we add up the 4 that we've actually got, what's the value of these 4? 52 is 60, it's 112, 114, 174, and 48 is 200 and, oh, I lost count. Let's try 122, 124, 174. I'm going to write that down. I lost count. 224. Okay, so we've got 224. So 4 boys is 224 kilograms, and it means that 5 boys we know in total weigh 280 kilograms. The last boy must be the difference between the two. So we can say here that the other boy weighs 280 minus 224, which is 50. Do you know what? I made an arithmetic error. Oh dear. Because it's only 120. It's 222, isn't it? You're all shouting at me to say, yeah, just look back. It's okay making mistakes as long as you discover them. That's what I always say. As long as you think, hang on. The reason I checked was that I did a wee adding of the units digits. 8 and 2 is 10 and 2 is 12. So the last digit had to be a 2. Okay, so I don't have a problem with making mistakes. I do have a problem if I don't kind of spot them in the end. So we've got 222. Sorry, my apologies. Now back on track. So we end up with 58 kilograms. So we can work back the way if we know. It's a nice little calculation that you can do. And lastly, now that we know all the 3 averages, what we can do is work them all out and think which is the best one. Is there a most appropriate one? So have a look at this, and then we're going to have a wee look through. A survey was taken of visitors to our website. So we've got all these ages. These are all ages. And we think, what's the average age of people visiting the site? Well, basically we have to work them out first of all. So it says find the mean, median, and mode. So I'm going to write them out in, rewrite them in numerical order because they're not in numerical order first. So the smallest one is 16, and then we've got 20, and then 24, and then we've got 33, 44, 41, and 44. And then we've got 53, and 65, and 65. Okay, so what we can say, we'll take the mode first because that's usually the easiest one to find. The mode is the most common one, and we can look along and see that there's 65 is repeated twice, so it means that the mode is 65 years old. The median is the middle number, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, so the median must be number 5, okay, because that's 4 to the left and 4 to the right, so the median, because they're in numerical order, is 41. And the last one, the mean, which I'm going to have to do a wee calculation for, going to add up all the numbers and then divide by 9. Okay, just for speed, at the moment I'm going to add them all up with my calculator, because you're going to be like, come on, finish this already. 65 and 65, I get 361. Okay, 361 divided by 9, and 361 divided by 9 is 40.1. Just round it down to 40 so that to the nearest whole number at that point. So here we go. These are the 3 averages. So which one is the best average to use? Well, quite clearly 65 is way at the top, and it happens to be because 2 of the ages were exactly the same. So you can see that sometimes an average appears which you think, hang on, that's not really typical. Okay, it just so happens it's just luck that two of them are exactly the same age. So sometimes we can discount them, and hopefully we think, do you know what? Let's not use 65. Sometimes you actually end up with a couple of averages that are very similar. So here we've got an average of 40 and 41. So I would say that it would be absolutely fine to use either of those averages. I'm going to go with 41 just because it's slightly towards the other average, but there's no other reason 40 would be fine. So I'm going to choose the median, and I'm going to write down I choose 41 as the average age. I'm not going to, I could write out a wee bit of explanation to basically say that I'm discounting the mode because it's not too near the top. I could have chosen 40 or 41. I'm going to take 41 just because it recognises the fact that there is an average which is higher than that, so I'm just going to go to one slightly bigger. So you might get asked that at some point, but that's the idea of comparing averages. It's a judgment call. There's never an absolute right answer, but there's a bit of a gut feeling in all of that as well. Okay, so you can go on and have a look at our mean average work. And then we're going to go on to look at range and also maybe using some of the averages to compare. Okay, hope that's been helpful.